Welcome to the WEKA Technical Demonstration Series. Today we're going to be talking about how to deploy WEKA on Microsoft Azure. As part of this, we're going to be covering an overview of the WEKA and Azure architecture together, where to get WEKA and Azure Terraform files to run, and then we're going to go straight into the demo showing how to actually deploy the Terraform file set and then running Terraform to get a full deployment of a WEKA cluster in Azure. So as an overview of the architecture, a WEKA on Microsoft Azure architecture uses Azure VMs to form a WEKA cluster. The cluster uses NVMe SSDs that are within those VMs as a high-performance tier. WEKA also has the ability to go ahead and tier off to an object storage, such as Azure Blob Storage, to get superior economics, but it's completely transparent to the applications. They don't know that the data has been moving. In addition to this, those particular applications can access the WEKA cluster across many protocols, whether it's POSIX, SMB, NFS, S3 native, or we also have a CSI driver that will allow integration with things like Azure Kubernetes Service. WEKA deploys on Azure using Terraform. In order to get WEKA Terraform automation files, you simply need to go to github.com/WEKA, and then once there, scroll down to the Terraform Azure WEKA repository, and then grab the set of files that are within there. Once you have those particular files, you'll go ahead and install them onto a server, and that'll provide the basis of your Terraform automation. So we're going to start this demo by actually putting a date stamp into place. I want to show you at the end of this how fast this entire process actually is. We start by going into the Terraform files that we downloaded before. As an example of how flexible this can be, if you go into the examples directory, you'll see that we have a number of different environments that we can provision using Terraform. Everything from private network, public network, multiple cluster. We do this to show that no matter what your environment looks like, WEKA has the ability to be provisioned and deployed within it. For this particular deployment, we're going to use the example of a very basic public network. To start, we go in and modify one of the files that tells you how it's going to deploy. We give a naming prefix, which is going to be added to all the resources that are created during the process within the Azure environment. We make sure that we have a resource group name that it's attached to. That resource group should already exist inside of Azure. Then you go ahead and add networking, the name of the cluster, and what type of instances you want to use. Currently, WEKA supports the LCV3 series of instances, all the way from the very smallest to the very largest one in that series. Give it your subscription ID for Azure, and then you set your capacity in sizing. Now, if you notice in sizing, there's two different options. You have the ability to add tiering, and then once you add tiering, what is the percentage that you want to? In the example we're going to do, we're going to go ahead and provision approximately 20 terabytes of NVMe SSD as part of the LSV3 instances, and the rest will actually be part of Azure Blob as an object store. The final part is you'll have to enter your get.weka.io token, which gives your Terraform automation the credentials needed to go and actually get WEKA from our repo and deploy it within Azure itself. Once you've edited all your parameters, go ahead and save and then type in Terraform plan. What this does is it queries Azure and determines how many new Azure items are going to need to be created or modified or destroyed in order for this entire Terraform deployment to happen. In this case, you can see that there's actually going to be 71 new items that are going to be added in. If you like what the plan says, then all you need to do is go in and type Terraform apply, sit back, and watch the entire deployment happen. For this particular demo, I'm going to speed up sections of it because it does take roughly half an hour to complete. And we don't want you sitting here and waiting the entire half an hour to see this demo go through. As I go through, though, you will be able to see as various resources created, how it shows up inside the Azure portal and dashboard, and all the different resource items that are created. I will slow it down in certain spots so you can see and highlight what these different actions are. As the demo moves forward, if we refresh the Azure web page, we can begin to see the various types of resources being built, starting with the various networking components within Azure. Note that it's already appended the prefix to each one of these resources. Following another refresh, we see other Azure services come up. Load balancing, import of secrets into the Key Vault, and the beginning of the building of the Azure instances themselves that WEKA will be loaded onto. After the Azure infrastructure is built, the next step is to load Linux into the system. Linux will be the foundational operating system that WEKA will then run on top of as part of the deployment. The process of loading WEKA on top of the Linux instances and then having it come together to form a coherent storage system, we call it clusterization. So you'll hear that term a little bit more later on. As you can see in the CLI, we're also invoking the Azure Virtual Machine Scale Set. This becomes important because later on we'll be able to show you auto-scaling, where you can go ahead and take a cluster of a certain size, expand it based on your needs, and also turn around and reduce the space, providing superior economics in terms of how much you have to spend on an ongoing basis to support your cluster environment. As you can see, all 71 resources from the Terraform plan have been added and applied. So the next step is that Terraform will give you a set of outputs that allow you to manipulate and manage your environment. We're going to go ahead and cut and paste these so that we can rapidly go ahead and just paste back and run these commands as needed to showcase what we're doing in this environment. Using this output that I've copied back in, we're going to call the Azure functions and see what the status of the WEKA install is on top of the instances. At this point, enough of WEKA is up and running on its various instances that we can actually use another one of these functions to go in and get the unique secret key for the password to the WEKA cluster. Now, one of the things that WEKA does is when we deploy, we automatically create a unique password for the cluster. This provides additional security because as you deploy, you don't wind up with the same baseline password. And in the cloud, with customers that may have multiple clusters and they keep iterating and repeating, having that additional level of security can be important. So we're going to go ahead and grab one of the public IP addresses for one of the instances that WEKA is running on, plug it into a web browser, and see if we can log into the WEKA cluster. And as is true for most demos that I do, there's always something that goes wrong. The WEKA GUI hasn't quite been instantiated yet. We'll come back to it in a few minutes and see if it's up and running. All right, let's try getting to the WEKA GUI again. There we go. Now that it's up and running and you can see this, we can log in. You'll see a couple things here in the UI that you need to be aware of. First off, while the UI is available, the cluster still is not fully clusterized yet. It's finalizing things it's doing. It's creating failure domains. It's registering the drives. It's making sure that stripe sets are in place, and it's beginning to build the actual WEKA file system itself. So you'll see a little bit of variability in things like capacity until it finishes that process. Now that the entire system has initialized and the cluster is fully up and running, we can see some of the other post-install processes that Terraform has put into place on the cluster. If we go into file systems, we'll see that Terraform has not only supplied a new file system group, but it's created a default file system. And if we dig in a little bit deeper on this particular file system, we'll see that it's already attached itself to Azure Blob, just as we specified in the original configuration file. You can see from the capacity here that, just like we specified, we have 20 terabytes of SSD, but 103 terabytes of total capacity, approximately that 80-20 blend like we originally put into the setup configuration file. And to give you an idea about how long this process actually took, we're going to run the date command again. Because we're on a different system, it shows up as UTC instead of EDT for the time frame. But if you convert them, you'll find the entire process took about 27 minutes start to finish. As you can see, deployment of WEKA in an Azure environment is extremely flexible, fast, and simple. It starts by just downloading a few Terraform files, modifying them, and then running the Terraform automation. Terraform then uses a combination of Azure APIs, scripts, and functions to build the Azure infrastructure, load the Linux OS, and then build the WEKA cluster on top of it. And as you saw, in only 27 minutes, that Terraform automation delivered a fully configured WEKA cluster ready to serve data. For more information, visit www.weka.io.